Well, hopefully you found that useful. And here's a few things I want to remember. I want you to remember from the reading, from the videos, what we covered is that the vast majority of Earth's water supply is contained in the oceans as saltwater. Okay? And as we saw from the percentages, the vast majority of our freshwater supply actually is locked up in icebergs and glaciers. But the water that we use kind of on a day-to-day basis, the largest source of that liquid fresh water, is actually groundwater. Now, these sources are not isolated from each other. Okay? And, we're going to take a look at this thing called the hydrologic cycle, and we'll see how they all interact here. But I just want you to know that these aren't like exclusively isolated from each other. They do interact. So a quick question, and we have a name for what we call this interaction between all those water sources. It's called the hydrologic cycle. Okay? And if you take a look at this picture, you can kind of see things going up, things going around, things coming down. So let's, take a quick tour of that. So let me start out by, what are the two primary ways that water gets to the atmosphere? Well, we have evaporation, okay, as shown here. Things like oceans, lakes, the water evaporates and goes up into the atmosphere. But we also have this thing called transpiration. Think of it as plants breathing out water. It's an evaporation of it in another form. So all of that goes up, and then it condenses, right? The process of condensation forms clouds. And then we have a thing called precipitation in the form of rain, snow, those kinds of things, where that water now comes back down to the earth. And then, especially like in the mountains and like that, the water will melt, run off down back into the lakes and streams, etc. And so we have this cycle called the hydrologic cycle. Now what I've done is I've made an extremely simplified version here. See, here's our transpiration, and I make this brown, so this is kind of like earth with the plants. Transpiration. And then you have evaporation. Now this is over the water, so the evaporation is the water going up from water sources. We have condensation in the clouds, and then it precipitates and comes back down. All right. Maybe that'll help, but I pass that on to you. Now, I didn't have you do experiment 5.1, but it's a nice, simple way to model the hydrologic cycle. So if you want to go check it out, there's this YouTube link has they've got a version of it that you can watch if you want to do that.
Welcome back to
Now, you may have run into this term called distillation, and it's where they use evaporation and condensation, excuse me, of a mixture to separate the mixture out into its individual components. For example, we've got ocean water that is salt water. If you're and I don't know if you know my background. I went to the Air Force Academy and went through survival training and some things. One of the things they taught us was if you're in a situation where you're, say, on the ocean and you need fresh water to drink, because if you drink salt water, you're just going to get more thirsty, you can use a thing called distillation. And it was the idea of using, setting up an apparatus where you could have the salt water evaporate onto a piece of glass, and then the fresh water would condensate on the glass and drip down, and then it would actually, the salt in the salt water would be left behind, and you would have fresh drinkable water. So that's just one practical example, but it gets used a lot in chemistry. But anyway, enough of that sidetrack. Let's get back to the hydrosphere. Right. So hopefully you see that we've got this water that's going, around in this cycle, and as it does, it depends on where it is, what type, where it is in the hydrologic. It's going to spend a certain amount of time in any given location, and that scientists have given that time a name. It's called residence time, and it's defined as the average time a given particle is going to stay in a system. Right, and if you remember from your textbook, you saw this table. I've kind of rearranged it a little easier to see, right? So this column lists the water source, whether it's the ocean or the glaciers and icebergs or groundwater, soil moisture, and lakes and swamps and rivers, or up in the atmosphere. And then we've got some estimated residence times. Okay. Well, this shouldn't surprise you that the ocean is around 4,000 years, considering that the vast majority of our water is the ocean, right? And as we'll see, and as you've seen in the percentages, the atmosphere is the smallest slice of the pie, and so the residence time is the shortest there. So, if you would, got a couple questions, graded questions for you. If you go take a look at those and get those answered, and then come back and join me with a continuation of the lecture, I'd appreciate it.